Hello. Well, we are going to start. My name is Alex, or Murphy, and I'm going to talk about how to use radar to patch iOS binaries. Okay? It's similar as Alvaro talked, but specifically for iOS. So, who I am? I'm a red team member working in Accent. It's a small enterprise and a startup. And as well, I'm managing and organizing the meetup, Barcelona Cybersecurity, for your interesting. So my main goal here is for that people that wants to learn how to use radar, and just to see a real example and how to use it, and as well how to create an R2 based tool specifically to analyze iOS applications. So that's the index. And first of all, we are going to talk about the binary format in iOS. That is the mach-o file layout. That specifically is just a mach-o header. And then it's just a binary streaming that is organized using as it's called load commands. A load command is just a small structure just to identify in which section in the binary you are. And then the whole binary is organized in segments, and each segment can have one or more sections. So we can have one mach-o, or we can have different mach-os in one binary. It's as it's called a fat mach-o file. Fat mach-o can have different mach-o files inside the same binary. And to identify the layouts, the offsets, you have a fat header just to identify the number of mach-o files that you have inside the fat mach-o. And then you have a fat arc structure for each mach-o file that you have. And inside the fat arc structure, as you can see, you have a field that is called offset, and with that offset, you know where is your mach-o file that you need to extract, to analyze, whatever. Mainly, we are going to use a command in radar that is called pf, that is to print or to define structures inside radar. And the syntax is quite easy. It's just to apply an structure that it really exists. Just write pf dot and the name of the structure that you have at and the address where that structure has to be. But maybe we want to print an structure that we don't have, and we have to define that structure. We can define that structure with the pf command, and it's just writing pf and space the name of the structure equal, and that is the format of that structure. In that case, we are defining a structure that has one x value, 4 bytes, 4 bytes, 4 bytes, and one string that is null terminated. And each field, we can define the names in the same command. And that structure, after defining it, we can use it inside the R2 session that we have. We can see different examples here. For example, how to print the fat header or the fat arc headers that we saw. Here, the only thing that we have to take into account is that the fat structure is in big endian. So we have to change the endianness. in the session. So we changed the configuration here at the beginning, and then here I'm defining an instructor for print just the fat mach-o header that we have two values, an X value and an integer value, that is the magic value and the number of mach-o files that we have inside, and then just apply it at the beginning of the file. And we can see the magic value, and that file has two mach-o files inside the fat mach-o. And then just printing the fat mach-o architecture structure for the first binary. Just define it here, and then print it in the actual offset, that it's 0x00 plus the size of the fat mach-o header that we defined before. That's the same for mach-o header. Here we don't need to define the structure because it's already defined. Just writing that command is enough. And if we want to print a segment as well, we have already defined the structure. Here we have the o2 command output that is pretty commonly used to extract information from iOS binaries, and how we can do it the same with r is the same. So it's pretty easy. Some interesting sections when you analyze an application in iOS. Some interesting sections in the binary that you maybe need to see. We have the segment text, and inside that segment you have different sections. First of all, the section text where you have the code or the strings of the binary, or that two that are specific for iOS binaries that has information for the Objective-C classes and methods that that binary is using. And how to extract that information using radar is easy, using the IC command, or even with rabin2 -c and the binary, and you have an output like that, where you have the classes, names, extract from that section, or the methods extract from that section as well. And you have already information from that binary. But in iOS, we have a problem. And the problem is that the binaries downloaded from App Store are encrypted. So that's the problem we are going to overcome today. That how to analyze a binary download from App Store to see the sections that we have seen before, and to analyze it, and how to overcome the encryption, and what happens if the binary is encrypted. That if we try to analyze, for example, or try to compile the binary, we can see some weird commands that has not make sense. Just if we try to extract the strings, just weird as well. And if we extract the class names, radar says that it's encrypted. So what do we have to do? We have to decrypt the binary, and we need to know where the binary is encrypted. So to know where it is encrypted, or to know if the binary is encrypted, we have to see a section, a load command section that it's called else encryption info, or else encryption info 64 if the binary is 64-bit. And as you can see, applying the same pf command, you can see the section. The binary is encrypted. The size of the binary, or the part of the binary is encrypted. The offset where the encryption binary starts, and just what defines that command. Okay. So what is the solution? The solution is that the binary is encrypted, but has to be decrypted to be executed. And is executed in memory, so the binary is decrypted in memory. So the solution is just go to the memory, go to the section where the binary is decrypted, and dump it. And we are going to see how to do that. So there's a tool that do that thing, and it's called Clutch. But that tool has some problems. That can decrypt some binaries, so it's not, you are not be able to decrypt some binaries. Decrypt everything, so if you have a fat mach-o with different binaries, decrypt all the binaries, even if you only want to decrypt one. And if you want to fix something, or just to manipulate something, it's a program with a lot, it's very big, so it's not able to see. Just, we have an alternative. We can do that, or try to do that with radar, and we are going to see what happens. So first of all, we need radar inside your iPhone. So you can put the radar using Cydia, the Cydia repo. But you can have the problem that maybe it's not updated. So you are not using the last version. So the best thing to do, choose from Git. It's quite easy. Just git clone, download it, execute sys/iOS Cydia, and it's going to be compiled. It's going to create a dev file. Just install it inside your iPhone, and then check the version, and it's from today. So you are pretty sure that you are using the last version of Radar. But well, I think it's already updated, so in Cydia it's as well updated, at least today. So just to check that Radar is working inside your iPhone. First of all, execute it with the ls command. It's working, you can print the binary, but you need to execute Radar in the debug mode. So execute a command as, for example, printing the memory maps with the dm command, and if it's working, yay, you have Radar in your iPhone, but maybe it's not. So what could be happening? In iOS, maybe you need to apply an indictment in your Radar binary. And you need to apply that XML using the ldit command, ldit command minus s in uppercase, and using it with that XML. Applying it into the Radar binary. And just to check if you did it well, you can do it with Radar as well, and just execute over Radar that command. And if you are seeing that XML is signed with entitlements correctly, so it's working. So now we are going to see all the steps that we have to do to decrypt a binary in iOS. First of all, just to check if you are working with a fat mach-o or a mach-o. If you are working with a fat mach-o, maybe you have to extract the mach-o that you are going to decrypt. Then identify if you have HLR enabled in the binary, means that the binary is compiled with PIA. And then just check the information for the encryption. And well, we are going to see all the steps in detail now. So first of all, we are going to extract a mach-o file from a fat mach-o. We can do it in two ways. Just using rabin2 minus x, and you are going to have two files more that each file is a mach-o file. Or you can do it for your own. Just as we can see, you have to read the fat mach-o header. So if you remember, the fat mach-o header is in big endian, so just change it in the session. Here we are reading the header. We have two binaries, so we are interested just in the first one. Okay, so just printing the offset with that command. What that command means? It means just print 4 bytes at that address, that is the size of that structure, that is value is 8 bytes plus 8, as you can see here, 4, 8. So we have to print that section, and then if you print, if you want to print only the value, you can parse it like that. And we have the bin offset, we have the bin size. So just move the pointer to the beginning of the file and just write to that file and that size. And then you are going to extract that mach-o to a file in your file system. So that's it. Second part, you have to read the mach-o file, and then you have to identify if P is enabled. So if the binary is compiled with program independent execution. You can do it just checking the SDB database, the string database that Brother is using with that command, with K and that namespace. And with that value, if that value is that value, so you have pi enabled. You can do it with SDB or with the ps command as well, as you can see here. Then just check the offset and the size, and first of all, if the binary is already encrypted or not. So we are going to see the LC encryption info section or loud command. How to know if we are in that load command? Just check that value, the command field, and if it's that value, it means that it's that structure, so it's 64-bit, and if it's that value, is that structure, and it's 32-bit. With the PF, you can extract the offset, the size, and with the SDB, you can extract that as well. The difference between one of them is the same, just it's how you are loading binary with Radar. If you are loading the binary in default mode, just without flags, or with / and n, just loading the binary in flat mode and with the header information. Yeah? So now we have all the information that we need. So we are going to dump the decryption part from the memory. So first of all, we need to know where the binary is loaded. So the base address of that binary. If P is enabled, it's just loading the binary with the bulk mode with -d and just printing the memory maps. And if we are going to see, just looking for the section with read and execution permissions, it's enough. And here we have the base address, that is that one. Or if it's non-pi, non-pia, just look at the text segment and in the field PM address. And that means that the binary always is going to be executed in that memory address. Yeah. So now we have the information. We know where the binary is going to be executed. So we're going to dump the decrypted part here from memory. Yeah. Just seek to the base address plus create offset and just dump the size. So easy. It's not so difficult. And then So we have the decrypted part in a binary, in a file disk. So we are going to patch the file into the file system. So here, the difference is that we need to check if we are working with a fat mach-o or a mach-o. If we are working with a fat mach-o, we need to know where is the binary offset that we are going to patch. If it's the first one, the second one, whatever. And just seek in the part of the binary that we need to know, just binary offset inside the fat mach-o, and then plus the correct offset inside the mach-o file. And then just write the part that we are already decrypted. And finally, the last part. Okay, we have the binary decrypted, but we need to modify one bit just to say that the binary is decrypted, it's not encrypted. Just to, if we want to execute that binary in an iPhone. So we need to modify just that field, crypt ID, and just printing the LC encryption info load command, writing in that offset plus 16, that is just to check here, and writing 00. And then if we print it again, now it's 0. So now the binary is decrypted, and we are saying that that binary is decrypted as well. So to do all that stuff, it's pretty annoying because it's time consuming all the time. So just automate that all the process with, I did it with a Python script using r2pipe and all that commands that you have already seen. Just with one execution, everything is done using Radar as a backend. So I have here a little demo where I'm just loading a binary. It's encrypted, so just look the sections, the classes are encrypted, and just dumping the strings, and everything is weird, it's encrypted, and I'm trying to decompile it to this assembly, sorry. And as you can see, it's weird as well, and it can be analyzed. So now, just execute the script. Just select the application that you want to decrypt, and just wait for 10 seconds, more or less. And it's doing all the process that I've told you. And now you have here a binary already decrypted, and we are going to check it just to that I'm not lying. It's a fat mach-o, so we have to extract the mach-o file inside the fat mach-o. We are going to execute Radar over the mach-o file, not the fat mach-o file, and then just execute the same. And now the classes are decrypted, and now the strings, you can see the strings, and if you try to disassemble the code, the text section, it makes sense, as you can see now. Yeah, you can see as well some call functions resolved. So, if it don't work, just improve the speed, because with some binaries it's too slow. Because you need to execute different r2pipe instances, or just to just trying to improve and to avoid repeat some work. just try to add some controls in of anti-cracking. That I'm not sure what I are doing, but yeah, there are some binaries that I can't decrypt. And just Python sucks, so try to do it in something more native. For example, Rust. I don't know. I have to check it before, and just add that script or program or whatever in some distribution repository, Cydia or r2pm or whatever. So that's it. Thank you for listening. And questions?
Very noob question. It's like super noob. Do we have to jailbreak the iPhone before installing CVS?
Yeah. You need a jailbreak iPhone to install Radar and to install Cydia and whatever. If not, it's not possible to.
Yeah.
But if you compile radar yourself,
Mm-hmm.
You still have to.
you put it on using like developer phone.
So what are the steps like before we install that software?
Just jailbreak your iPhone and then compile Radar, copy the deb file into your iPhone, and just execute the PKJ -G, I in the line, sorry, and the package. That's it.
And we don't have a jailbreak for that.
Yeah, you need jailbreak.
Oh, you need jailbreak.
Yeah. At the moment, you need jailbreak always.
Jailbreak anyway.
Yeah. If not, fuck. No? Okay, thank you.